Relational databases get their name because they store data in a series of entities or tables that are related to each other using keys. These relationships allow data to be entered and stored only once, but used repeatedly throughout the database. This is a big difference from flat files that can require the same data to be entered repeatedly. Let me give you an example. The flat file you see here, an Excel worksheet, is being used to store patient appointments. Whenever a provider is assigned to an appointment, all of the provider's information has to be entered. You can see it here with providers 1105 and 1108. In addition to using up employee time and disk storage space, entering the same data repeatedly dramatically increases the chance for errors, which affects searches and performance metrics. As flat files grow, they can become cumbersome and increasingly difficult to read and interpret. Relational databases are not a cure-all, but they can be great tools for storing, accessing, and analyzing information. Let's take a look at a small relational database designed to create and track patient appointments. Databases, regardless of their size, typically contain four primary components: tables, which are used to store the data; queries, used to pull information out of the database; forms, used to enter information into the database; and reports, which can display the information in an easy-to-read format. We're using three tables in this database: patients, providers, and appointments. When you look at the patients table, you see pretty much what you would expect to see: name, address, email, phone number. But I want to discuss one field in particular, the patient number. This field is used to assign a unique identifier to each patient. In fact, this table is set up to automatically generate this number when a new patient is created, and it will not allow a duplicate of that value in this column. If a patient is deleted, that value will not be used again by the database. Earlier in this module, you heard this value in a field like this called a primary key. A row of cells, or fields as they are called in databases, is called a record. The primary key uniquely identifies a record. When you look at the providers table, you see a very similar layout. In this table, the provider number field is the primary key that's used to uniquely identify each provider record. When you look at the appointments table, one of the first things you notice is that there are no names. This was done on purpose. One of the foundations of database practice is to do your best to only store information once. This practice dramatically reduces the size of the database. Remember how big that flat file was getting because we repeatedly entered all that information? And it improves searchability. So how do I get to those names if I need them? The key is in the keys. Like the other tables, the appointments table has a primary key, appointment number, that uniquely identifies each appointment. Additionally, this table has two other fields with key values: the patient number, which is the primary key for the patients table, and the provider number, which is the primary key for the providers table. When a primary key from one table is used as a field in another table, it is called a foreign key. A foreign key links the new table to the foreign key's primary table and creates a path that can be used to gather information when needed. This link also establishes a relationship between the two tables. Remember in the flat file where each appointment required entering and re-entering all that patient and provider information? Now take a look at patient 12 who's made several appointments, and provider 1119 who's been assigned several appointments. In the appointments table, the relationship between the tables allows the same patient and provider records to be used repeatedly as a data source. In other words, one patient or provider record can be used many times. As you saw earlier in the training module, this is called a one-to-many relationship. Instead of thousands of repetitions of the same data, the relationship allows you to use the same information over and over again. You can see the relationships between tables by looking at the entity relationship diagram. Notice how the patient and provider foreign keys are connected to their primary tables. The little infinity symbols next to the connections with the appointments table tell you that they are many relationships. Now, let me show you how to get those missing names when you need them. As I said a moment ago, relationships let us fetch and reuse information instead of typing it in over and over again. If you want to enter a new appointment directly into the appointments table, which you can do if you want to, it can be a challenge to remember which number goes with which patient or provider. A great data entry tool is the database form, which leverages relationships to make data entry easier. I'm going to create a new appointment to show you what I mean. To create a new appointment, I'll switch to the appointments form and then go down to the bottom of the form and click on the new record icon. Now what this does is it takes us to the bottom of that appointments table and sets us up on a new row to enter the data. I like using forms because if I have a very large table with thousands or tens of thousands of records, I don't want to have to scroll to that to start entering data. Notice how the current date has already been entered into the transaction date field. Again, this is something that you can set up as a default in the database, and it guarantees that the correct date in the correct format is entered in that important field. To add a patient, I've provided a drop down here, and when I click on that, it uses that relationship and goes out to the patients table and grabs all that information, showing me the patient number, which is actually stored in the appointments table, plus the patient's first name and last name, so that I can confirm that I'm making the right choice. So I don't have to remember the name associated with the patient number. When I click on that, it now fills in that first name and last name for me. I'm a big believer in drop downs, and you've probably seen them many times when you've filled out online forms, particularly the drop down for the state two-letter designators, because you don't want to take a chance on somebody mistyping that and skewing your data. And there's always someone that believes the two-letter designator for Florida is FLA. Notice also that as soon as I added information to this form, it automatically generated an appointment number. Now remember, this is the primary key used to uniquely identify this record, and by doing it automatically, it doesn't have to worry about me forgetting to do it or doing it incorrectly. When I added the appointment date field to this form, it automatically gave me a date checker icon that I can click on and choose the date that I want to set the appointment for, and it automatically inserts that into the table in the correct format so that I don't have to worry about mistyping it. When I added the appointment time field, I set it up so that it would have a data validation rule. And a data validation rule means that the information has to be configured a certain way. Let me show you what I'm talking about. We're going to do this at 10 o'clock, but I'm not going to tell it if it's 10 o'clock in the morning or 10 o'clock in the afternoon. When I try to go to the next field, it gives me an error that tells me it wasn't in the appropriate format, or input mask is the right word, that the official database word. But it's basically saying, hey, you didn't enter this the correct way. So I click OK, and I go back and I type in AM, and then I can go to the next field, and that basically works the same way that the patient's field. I'm going to put in the provider name, first name and last name, and I'm good to go. Just like a form, queries can leverage those relationships to gather information from all the tables in a database in response to your request for data. Let's say that you've been asked to create a list of the appointments that has the patient's first and last name, the provider's last name, and the appointment date and time. So you create a query that when you run it, it reaches out to the different tables and gives you something that looks like this. Now notice there are no primary keys here. There are no foreign keys. In fact, you only have two fields from the appointment table, the appointment date and the appointment time. It uses the relationship, the query does, to go and grab those other fields from the other tables and put them in the form that you see here. A lot of people shy away from using databases because they're afraid they don't have the horsepower to create queries like this to effectively get all that information from their database, or to even build the relationships that allow that information to be gathered. Don't be intimidated. The popular database applications have tools to help even beginners create powerful queries. The database that I'm using here is Microsoft Access 2010, and it has a great design tool for queries. Let me switch to Design View. And notice how our relationships are in there connecting the tables. This design tool lets me use drag and drop to add fields to my query and my query results. So let's add the patient telephone number so that I can give them a reminder before their appointment. I'm going to grab it up here and just drag it down to the next column and let it go, and now it's in there. To make sure it works, I click on the Run button, and now we have the telephone number added to our query results. Going back to Design View, there is a row down here called Criteria. Now, I'm not going to go into the detail on that today, but I can add criteria to a query, for example, so that I only have patients who are male, whose provider is 1119, and whose appointments are before 10 o'clock in the morning. A lot of different things you can do with queries when you add criteria. Before I close, I want to spend just a few seconds on reports. If you don't like this tabular view that you get from running a query or from looking at one of the tables, you can use reports to present your information in a more pleasing or possibly easier to understand format. A report like this one shows the pertinent information. In fact, this report is based on a query. When I opened up the report, it ran the query, fetched the information, and then placed it in this format. And I could just scroll down and look at all the information on all of my appointments. So reports are a great way to show information in something different than just a table. And this is also a great way to show thousands of records in a way that can't overwhelm your eyes, as is often the case when you're looking at a table. That wraps up this segment on relational databases. I gave you a quick overview of the main components of a database, tables, forms, queries, and reports, and demonstrated how you can leverage the relationships between database tables to use data many times and many ways, even though it's been entered in the database only once. I encourage everyone, particularly new users, to explore using relational databases to make their informatics tasks less complex and more efficient. This is John Sistrunk with the Veterans Health Administration's Office of Informatics and Information Governance. Take care.